Okay, now I
There we go. It is recording. So that was my biggest worry, that I would forget to hit record, but thank you for whoever just did that. But I will get us started with today's seminar speaker. I want to welcome Dr. Heather Bailey as our speaker today. Dr. Bailey is an assistant professor in psychological sciences at Kansas State. Her broad research interest is in age-related differences in memory and working memory systems. In terms of Dr. Bailey's background, she is a cognitive and experimental psychologist by training, earning her master's degree in experimental psychology at Wake Forest before moving on to a PhD at Kent State and then doing her postdoctoral training at WashU in St. Louis. Dr. Bailey has multiple NIH awards to her credit, including a current R1 focused on the role of prior knowledge and event processing in aging and in Alzheimer's disease. She's also been a wonderful partner on a personal note on a current NIH-funded study that we are conducting looking at the effects of premutation alleles of the Fragile X gene, or FMR1, on aging. Today, she's going to be talking about perception and memory of everyday events in older adults. So please join me in welcoming Dr. Heather Bailey.
Thank you, guys. I realized that nowhere on my slides does it say I'm from K-State. So it's unusual not to have a purple background for me. But anyway. And
I thought you might have been intimidated in front of a KU audience.
Right.
Please
I
don't.
had to go with some
Rivalries
variation of blue.
are left at the door. There you go.
Right. And I apologize. I'm like just kicking some virus, and I'm at home with a sick kid and trying to keep kids and dogs out of screen. So we'll see. It's like harkens back to pandemic days. So I apologize. And if I have to stop and cough, just forgive me. So I'm really excited to be sharing a lot of the work that we've been doing, that the lab has been working on over the past 5-6 years. And I know this might be a slightly different population than you guys are used to talking about, but I love talking to people from different perspectives and backgrounds, and just love to hear, any questions or ideas you have. And I am good with going pretty informal. So if you've got any questions, just interrupt, especially clarification ones. So but as Matt had mentioned, I'm going to be talking about how, or age-related differences in how people perceive and remember real-world events. And I do so because one of the most popular complaints amongst older individuals is memory loss. And they have a right to make these complaints because there's thousands and thousands of papers documenting age-related declines in episodic memory. And when I say episodic memory, I'm referring to our memory for very specific events, like where did you park your car today? What did you eat for dinner last night? Who told you that funny story? But what I find really interesting, though, is that although episodic memory is declining, we see that semantic memory, or our memory for facts and knowledge, actually remains intact, or may even increase as we get older based on just years and years of experience and that has just been gathered over a lifetime. So there's been this reemergence in the cognitive and the memory field that has been looking at the intersection between episodic and semantic memory, and my lab fits in that zone right there. But we are kind of in a slightly different lane from some of the historical work on episodic memory, in that we do focus on dynamic real-world experiences, so that things that map onto more like real-world experiences that our older adults may face. And just to give you guys an example of a stimulus that we may use, sometimes we use Hollywood films too. I could speak to that, or we use narrative text. But a lot of times it might just be a simple video that we've filmed in the lab here with a fixed point camera that involves one actor performing one simple everyday activity, such as this woman who is going to be potting flowers. And Matt, if you guys were a participant in our experiment, while you are sitting here watching this video, your brain is not storing this activity as a continuous reel. Even though this is how we're perceiving it, as a continuous activity, our brain is actually naturally splicing it up or segmenting it into meaningful, discrete events. And based on neuroimaging work in the past, we know that the segmentation of these events happens naturally because we see these transient increases at moments throughout the video that people later will say there's a change when one event is ending and a new one is beginning. So we can have people lie in the scanner and watch these videos and track brain activity at these important changes, or in the laboratory in a behavioral testing scenario, I can just ask people to press a button each time that they think one part of an activity is ending and a new part is beginning. This is a very, very subjective experience, though. I don't have an objective scoring rubric to say that somebody is 100% correct or not. So instead, what we do is we kind of crowdsource our data. So we have a large group of people watch the video, press the button, and like what I've got plotted here is every moment in the video. So every frame that through like a 5-minute video. And averaging across individuals in our sample, we get this smoothed probability or histogram, essentially, but the probability that people perceive what we call an event boundary. So just the event boundary is that moment in time where when one part is ending and a new part is beginning. Like maybe when she finishes pouring the soil into the pot and moves on to planting one of the flowers, for instance. So there are multiple event boundaries that people identify throughout the video. And what I've got here on this slide is data from one of our experiments, again, with time or the frames plotted on the x-axis and the probability that somebody perceives an event boundary on the y. And you could see, based on this, a few observations here, that it's actually, to me, it's like an actual impressive amount of agreement or consensus between people, given all of the possibilities that any given point in the video, you could press a button and perceive this subjective experience of an event boundary. But we get a lot of agreement. But there are also individual differences because obviously we're not hitting 100% in each of these locations where we would later call an event boundary. And we're getting like a lot of little random hits throughout. And you can also see that the differences between the younger and older adults, where we tend to get more agreement or more consensus within our younger participants. And our older adults, a large portion of them perceive the same event boundaries that our young adults do, but we tend to also get more idiosyncratic boundaries as well within older adults. So I started talking about memory and now I'm telling you guys about event segmentation. Well, why is that? And the reason is because we have found that the way that you segment the activity during encoding is predictive of your later memory performance. And and this is true for the more like, okay, and I should back this up. The way that we measure segmentation ability is I can compare one person's button press with the rest of the group. So it's essentially just a correlation between each individual's perceptions compared to that of the rest of the sample or a larger population of people. And we found this within young adults, we found this within healthy adults, and we've even found this within people with older adults in the earliest stages of Alzheimer's. So in that group, which everybody's very familiar, has pretty drastic episodic memory declines. So they're in like a really restricted range of memory performance, but even within that group, there are individual differences in how they perceive and break up these activities, and it is related to how well they later remember it. So I kind of tend to think of this as a unconscious encoding strategy. We're not consciously aware that our brain is doing this, but it is a way that our brain is organizing information in time. And that helps us kind of deal with all that continuous input that our perceptual system encounters during all of our waking moments. So just like to recap that brief introduction that our brain is segmenting the continuous activity into discrete events, and the perception of those events helps shape our memory for later. And that this whole process becomes more idiosyncratic with age. And so what the new spin on some of the work that my lab was working on was going back to that first slide is, can older adults leverage their intact semantic memory or their prior knowledge for an activity to help them learn novel but relevant new information. And does this prior knowledge help them perceive event boundaries, important boundaries? Does it help them remember information later? And so I'm going to give you guys a brief overview of the paradigm, the basic paradigm that I'm going to use, that we use in all of the studies that I'm going to report today. So we bring young and older adults into the lab, and we have them most of the time watch a video of everyday events, like the gardening video that I showed you earlier. But what we've done is just manipulate the content of the activity so that it's more or less familiar to one age group or the other. So we've got some activities for which our older participants are more familiar with, like gardening or balancing a checkbook, or activities that our young adults are more familiar with, like setting up a game console or a printer. And I know that this is not the optimal way to test knowledge or familiarity, because there are individual differences within each of these age groups, right? Some of my older adults may not be familiar with balancing the checkbook because their spouse may do it, or some of my young adults may not play video games. And I fully agree and understand that, but I'm happy to answer questions about this process. But we spent like just shy of a year extensively piloting, like identifying these activities and piloting. And essentially what it comes down to is that we have found activities for which our older adults can produce richer or more detailed scripts, or like if you list off the sequence of steps involved in these sort of tasks, that our older adults are able to produce more knowledgeable information about these, and our young adults are better at producing scripts for the young adult activities. So do I have any questions about the background or the basic paradigm before I get to data? Make sure I've got everybody with me. Okay.
Heather, I have a question real quick.
Yeah.
If you're pausing for a moment.
Yeah.
It was really interesting looking at the plots that you showed, the probability plots with the red and the black lines. And it looked like the older adults were more idiosyncratic, but could you just clarify, I guess, in terms of the uh I guess I can kind of see it in there. They're more idiosyncratic, but I also just wondered, they seem to be also identifying more events or more segments. And I don't know, I'm
Yeah,
not
that's a
clear what
good
the
point.
significance of that is to actually memory formation.
We had looked at that at one point to see the number. There has been work from other labs that have found that novices within an area tend to, like, there was a Dutch group, I believe, that had done this sort of segmentation task with dancers. And they could be either complete novices or students in the first day of a dance class. They'd have them segment, and then they would have them learn the choreography and then have them segment it later. And they found that when you're novices or very unfamiliar with the routine, people segmented more. It kind of relates to what we know about chunking, like chess experts, right? They see the board instead of individual pieces. And so we may be able to kind of make that somewhat of a comparison where with with more knowledge or more experience, you might start lumping more and more of these activities into one larger event before. But there's something that our labs talked about doing is some signal detection ideas to see if there's a bias or a criterion that where people may be more or less conservative in their button presses. And I can return to that because some of these data don't line up with some neurophysiological data that we're struggling with. So yeah.
Interesting. It's interesting to put that in context of like expertise and
Mm.
mortgage versus piecemeal, kind
Mm-hmm.
of breaking things down, which
Yeah.
this just suggests more piecemeal, which seems like it would be maladaptive for actually consolidating the information, or there's more information
Right.
to remember.
Right. It could be like a burden on working memory if you're constantly got these little tiny units that you're dealing with. Rather, if this button press data is valid, I guess, right? So yeah, but definitely it is something that we've thought about. And I've had other students in the lab who have looked at expert novice effects outside of aging or and then like I mentioned, these other European groups have as well. So I'm happy to answer any more that I can, if anybody has any follow-up.
No, that's helpful. Thank you.
Yeah. So the overarching question for these next few studies were, does prior knowledge influence how people segment and encode an everyday activity? So what I've got here, plotted here, is age on the x-axis and segmentation ability on the y. So higher values on the y-axis mean better segmentation. And familiar activities are in green and unfamiliar are in pink. And we found that overall, both groups did a little bit better when they were watching familiar activities. They were better able to identify normative event boundaries in the familiar versus the unfamiliar activities. Not a whopping effect, though, but there's something there, but there's no interaction, age by knowledge interaction. So everybody seems to be getting a little bit of a benefit, but I will say that the button press task is not my favorite, especially for an aging population, because it's essentially forcing them into a dual task paradigm, because they're trying to learn and encode the activity in the video, while at the same time maintaining that goal to press a button whenever an event is ending. And every now and then we will get people that just forget to press the button overall because they valued the video viewing over the button pressing. And there are other issues that I'm happy to chat about too. So what we did was follow this up with a more covert measure where we downsampled the videos and took screenshots or still images from every 1 second in the video and created a slideshow, a self-paced slideshow, essentially. And they were allowed to just view each of these images as long as they wanted. And unbeknownst to them, we were recording how long they spent on each image. And what's important is that in some of these images, it's just got information from the middle of an unfolding event. Not many changes happening, just kind of the continuation of the current event. Then in others, we've got images that depict an event boundary, when one event is ending and a new one is about to start. And so the prediction based on work from other labs is that people should slow down at an event boundary because there's more information in that, and they should slow down and update their mental model at that point. And we do see that. So everybody's slowing down at event boundaries. So I've got the young and older adults on the x-axis again, and I've got viewing time. So longer viewing times we assume means more attention to that image. And then familiars in green and unfamiliar in pink again. And so overall, people are slowing down at event boundaries, but they're doing so more so when they're familiar with the activity, and especially within our older adults. So when they've got that prior knowledge, it may make them more sensitive to detecting those important changes, and they're slowing down and potentially updating their working memory mental model to reflect the new event that's coming up. And we also replicate decades of data. Like we talked about the expertise effects that memory is better for familiar information. When you have prior knowledge, you remember more. And we show that classic young adults outperform older adults on these episodic memory tests. But what was really nice to see here is that the older adults are performing much better whenever, and they're looking more similar to the younger adult group whenever they have these past experiences that they could rely on. So we've shown that people are able, with the prior knowledge, are able to slow down and detect these important changes. I should have mentioned these event boundaries we kind of think of as like anchors in memory. They help, they're really important. Our memory is better for the event boundaries. If you remove event boundaries from a video, comprehension tanks. It's hard to understand what the video is about if you remove those change points. And so if you're able to slow down, detect them, process them, it should be no surprise that memory is better as well. But what we don't know is specifically when they're slowing down to look at the event boundaries, when they're allowed to pace themselves, we don't know what they're actually looking at. So in the next set of studies, we ran an eye tracking study using the same videos and young and older adults, same manipulation. But we had 2 dependent variables of interest. And the first one was gaze similarity. And that is, are they looking, or to what extent are they looking at the same place at the same point in time? So it's kind of a dynamic a way of looking at like dynamic eye movements as a group. And then in the second one, we're interested in an area of interest to specifically see if they're looking at goal relevant information. So I'll go through each of these in time. So I just took the same video that I showed earlier, and my amazing previous grad student created some script. So he could plot out each individual blue circle on there is one participant's eye movement for every frame in the video, or every eye movement that they make throughout the video. And then he overlaid a heat map so that the more dense or more clustering that there was, the hotter the colors, and then the more spread that the eye movements were, the cooler the colors. And you can see there are moments in time. Let me see, like where it's like a lot of clustering, like a lot of people looking at the same place at the same time. But then there are other times throughout the video where it's spread out, like lots of things to look at. So what we're measuring are those dynamics over the whole video, and then how would that differ by age group? And so we're getting a measure of similarity, so how close they are in XY coordinates compared to the group. And we show that across all videos. So higher values on the y-axis are more similar eye movements to the group. And I've got young and old on the X again. And then just overall, young adults are showing more gaze similarity compared to older adults. And another colleague had actually looked at something similar and found the same effect in a Hollywood style video, and claimed that it might be due to young adults like better attentional control, their ability to control their attention throughout the video to the important parts of the screen. But what we're more interested in is what fluctuations happen throughout the video, especially at event boundaries. So I might be going through these too fast. Are there any questions yet? I just hope you guys would interrupt if you have some. Okay, just feel free to jump in. But what I've got plotted is that before that was like the aggregated data across the entire video, but now I've got the dynamics of the gaze similarity throughout the video with young adults in that yellowish color and the older adults in blue. And overall, though, there is a striking similarity between the young and older adults, but there is a reliable age difference where the young adults are showing slightly higher values throughout the video. But what we're mostly interested in, the new part of this, was looking at what are those peaks in the gaze similarity. Are those aligning with event boundaries? So what I've got here in the green bars are the where the event boundaries were located. And for the most part, yeah, they were lining up with, so the moments in time where people's attention is drawn to the same place at the same time tend to be near the event boundaries. And so what we did was average across each of these event boundaries and then look at the time course around the boundary, which is here. So over time, leading up to the event boundary and immediately following the event boundary, you're seeing that attention, eye movement's a little bit more spread up until you get to the event boundary. And then we're seeing a peak as you hit the event boundary, and then it decreases afterwards. And we are still seeing that main effective age. So we see a main effective time where there's a change in time over here, and then there is a main effective age, but there's no interaction. So interestingly, young and older adults are both showing some capturing of attention, some similarity happening around the event boundary. And the first people to show this, so we honestly are still trying to explore, more work needs to be done on this. But we think that it's possible that when things are changing, there is enough happening, that something important, something conceptual is happening that is driving people to look at specific parts of the screen. We don't know what yet based on these analyses. But then once you hit the event boundary and something new is happening here, that similarity decreases, probably because the new event is being set up and there might be more exploratory eye movements. So for instance, when she finishes bringing in all of the supplies for potting the flowers, that event's ending, and then people are not really sure what's going to happen next. Is she going to grab the soil? Is she going to put on her gloves? And so there might be more exploring of the scene to try to understand what's going to happen next and what's on screen currently. And I should say that this may not look like a majorly impressive increase, but we have controlled for perceptual change that happens because there's a lot more movement and perceptual change near an event boundary. So we have to control for things like color and luminance, etc. And so this was a lot higher before controlling for that. But even after you control for some of these like low level things that can affect eye movements, we still get this reliable increase and decrease pre and post boundary. So that's cool. Like they're looking at the same thing. Something about an event boundary is capturing people's attention similarly, but what is it that they're looking at? And so that was the next analysis we ran. And my poor students had to go through the entire video and they documented every goal and sub goal and when they were completed. And then on every single frame of every video, they had to draw an area of interest around the objects that the actor that was associated with the actor's current goal. So if her current goal was to plug in the cord into the power strip, then we drew a box around her hand and the cord and the power strip. And what we looked at, we calculated the proportion of fixations throughout the video that landed within the area of interest. And we had to control for the size of the interest area because sometimes they were large. The interest areas could be really large, like across the whole, around the whole bag of soil, or really small, depending on the object. So we wanted to know how often are people looking at goal relevant information. And again, we found I've got age group on the x-axis and the proportion of fixations on the y. And excuse me, we found that for young adults, it didn't really matter if they were familiar or unfamiliar with the activity, that they were just under 50% of their eye movements, of their fixations were landing within the goal relevant regions. But for older adults, they really benefited from that prior knowledge. So if, like, for instance, in the balancing the checkbook video, if they knew what that actor's intentions were, what their goals were at that given moment, they were better tracking that information and attending to it and moving their eyes towards it. But they, whenever they didn't have that prior knowledge, they were less likely to be looking at the goal relevant, like the really important parts of the screen. So this could be accounting for some of the comprehension and memory differences here. So yeah, I see. If I don't know if anybody has any, I'm going through these quickly. I know I'm not slowing down for a lot of the methods details, so let me know.
Real
Yeah.
quick, I'd ask a question on that one. But does this have anything to do with processing speed? So if they are encoding like an unfamiliar
Mm.
context situation, you're looking at where they're attending.
Mm-hmm.
I mean, is it trying to process, a lot of new information
Mm-hmm.
and then being able to shift gaze to key objects or key items
Yeah, that's a great
in a timely
question.
manner, or
Yeah,
yeah,
we've looked at that with
process.
segmentation. I've had an undergraduate who ended up doing some like partial correlations because we always collect processing speed.
Mhm.
And they found that when you controlled for processing speed, that the age differences in segmentation ability decreased a bit too. So meaning like processing speed and motor speed could be
Mhm.
leading to like a delayed button press too. But we haven't looked at that in terms of like lagging eye movements. That could be interesting though. Um, if we kind of shuffled those I don't know, like a couple frames forward, is that
Mhm.
when the older adult's making that eye movement? That could be interesting
Yeah.
because those areas of interest are always moving, but if they're
Right.
if they're lagging a bit, they wouldn't be getting credit for it in these analyses.
Right.
Yeah.
It would suggest not necessarily a different approach or attentional
Yeah.
modulation, but rather just the ability to
Yeah.
rapidly adjust in real
Yeah.
time.
That's a good question because right now I've got a student who's working on, she has created heat maps, like saliency maps. So looking at, so what we were looking at on this is conceptually important. pieces of information on the screen at any given moment. She's creating salience maps for like low level, bottom up sort of things that might capture your attention that aren't meaningful, like
Right.
motion, color, that sort of stuff. And we were trying to see, she wants to evaluate like what's happening with where are they looking at the other 65% of the time. So maybe that could address it. We had another student who's proposed that they might be just looking at faces of the character, if they don't know exactly
Yeah.
what's happening, they may not be looking at the hands, but they may be looking more at the actors' faces. So we're still trying to, yeah, there's a lot of data in this. So but that could be interesting in terms of processing speed. Yeah, I'm gonna jot that down. Could look at that. Thanks. Any other questions or comments? Okay. So like just an interim conclusion right now. So far, I've shown data that when older adults have access to prior knowledge, they show an increased ability to track goals via their eye movements. They show increased ability sensitivity to identifying these event boundaries and better memory for the activities at the time. So that's with the behavioral work, what we've shown. But in the last study, I wanted to go through what's happening in the brain and try to reconcile some of these results together. So our same old videos, it took like a year to film these and write the scripts and so forth. So we use the heck out of them, but now they're sitting on a shelf. So anyway, same videos, same manipulation, young and older adults, scanned at Hoagland. And what their instructions were they, when they were in the scanner, they watched these videos and they were just told to view the movies and pay attention because their memory would be tested later. And then we pull them out of the scanner. They complete these various memory measures for the memory for the activities and the activity in the videos. And then they did that button press task and then completed some familiarity ratings for the activities in the video. So this is passive viewing. They were not told to segment anything, told to watch the movie. And we replicate some past work. Remember, it said that there's a transient increase in a smattering of brain regions at these event boundaries. And I want to point out that we use a pretty strong control in these studies that we are using brain activity around in a window of time around the event boundary compared to the brain activity watching the rest of the video. So we're not comparing it to fixation. So, I mean, there's minor differences, right? From when she's pouring the soil to when she puts it down and picks up a flower, but there are conceptual changes that happen there too. So it's just what we think this is reflecting is some mental model updating. So my mental model for pouring soil has been updated and now it's planting flowers or whatever they're watching at the time. But we do find a main effect of time around the event boundary. So, and I should note that past studies have shown that this effect is even larger if they're told to pay attention to the event boundaries. So if you draw more attention to the event boundaries, these same regions just show an even stronger increase around the boundary. But oddly, no different. No, we found no main effect of age. So young and older adults are activating the same regions at the same points in time to the same extent. And I shouldn't say that's incredibly surprising because there has been another group that have shown that there was a null age effect. But I think even more surprising for us was that there was no interaction with prior knowledge. So maybe this univariate effect isn't really sensitive to these knowledge manipulation. But so maybe I should slow down and see like Matt scowling. Okay, just want to make sure if anybody had any questions on that. But we tried to dig in a little bit more deeper and focus in on two specific regions, the medial prefrontal cortex and the hippocampus, because amongst all the other processes that they're associated with, the hippocampus is known to be activated when we're detecting something novel in our environment that needs to be encoded. And the medial prefrontal cortex is activated when we're detecting familiarity within our environment. So the thought was that these two work together to integrate new information with existing knowledge. So you can even think within these videos, I may be quite familiar with potting flowers, but I've never seen this woman potting these specific flowers and this specific sequence of steps. So there's always some novelty in these videos, even if they are familiar with them. But we thought that, so we looked at um, functional connectivity between these two regions throughout the video and thought that there may be an interaction with familiarity. So the more familiar you are, the more connectivity throughout the video that we would observe. So what I've got plotted here is age group on the X, and then this is functional connectivity on the Y for the entire video. So it's kind of a gross level analysis here, just the extent to which the activation in these regions are correlated over time. And it's controlling partial correlation with the primary visual cortex too, and then Z scored. But overall, though, all we see across videos, across conditions, is that young adults show more connectivity than older adults. So we're seeing this main effect of age and no interaction with prior knowledge. So just to see, like, is this a meaningful measure? Other people have used something similar in young adults, but nobody's looked at this in older adults to our knowledge. So we wanted to say, does this variable actually predict memory? You know, if these regions are working together to so presumably encode, effectively encode this information, does it predict memory? So I'm tricking you guys here. I'm flipping the axes. Sorry about that. We've got connectivity on the y-axis, I mean on the x-axis, and then memory performance on the y. So I've got different measures of memory, like recall, recognition, etc. And young adults are in that bluish tealish color. And they're showing the pattern that we would expect, that the more in sync these regions are while viewing these movies. And this is average across, since we found no effective knowledge, we just averaged across all videos. So the more functional connectivity within a young adult, the better the memory. But individual differences in connectivity between these regions in older adults did not predict older adults' memory. So we're a little bit stumped. We've looked through other candidate regions that may be working with either of these regions, or but really, like, the main thing that we're actually focusing on right now is getting more fine-grained and looking at connectivity and at event boundaries too, to see if maybe the connectivity may wax and wane as the events unfold. So we're currently looking at that, like, right now. Yeah, Matt.
Sorry to have multiple questions, but
Oh.
it's interesting data. Have you thought at all about, and maybe you've already looked at it, but I'm just thinking about, the premise for looking at functional connectivity certainly seems relatively obvious, but I wonder if you've just looked at like local circuit activation, and whether, as individuals age, that may be a reorganization of memory systems,
Mm.
such as they may be represented more locally, or memory processes may be represented more locally as opposed to within network metrics.
Yeah, no, I haven't. We haven't at all, and there's not much to go by in our little field here. Everybody's looking at this either in rodents or in young adults.
Mm-hmm.
So, yeah, we're trying to borrow from other literatures, but that is a definite possibility. I've had Ryan Townley also given something kind of similar, and he was from the ADRC, and he had suggested also potentially looking at some interactions with like Percunius, like some of the, like, there may be like a third party involved, kind of, and like similar idea, but no, I haven't, though. We haven't looked at this. Yeah.
It would
John.
seem odd if different nodes started to become involved, as opposed to maybe
Yeah.
this a reorganization from like network to local organization. But
Mhm.
just a thought.
Yeah. Yeah. And the in the aging and memory field too, one of like the big uh discovery over like the last 20-30 years in terms of neuroscience was that um high performing older adults that behave like young adults in terms of memory performance are typically activating bilaterally, whereas the low performing older adults, their brain activation looks like young adults. So they may only use like left prefrontal cortex. But we've been trying to sift through theories like what else are we missing here to figure out like what other analyses can we be running. So yeah, if anybody has any more thoughts, we're like in the process of writing this up right now and just kind of hitting a wall with the older adults, I think. So it's kind of unsatisfying. You don't have like can't tie up the bow, really. You've got like this nice story with young adults, but what's happening with the older adults? So love any ideas. So I'm jotting these down, taking notes. So um that's really the end of the data. I probably could throw more graphs at you or what, but really the take home message is that, or how we're interpreting this is that because of older adults degraded episodic and executive functions, etc., that they are potentially more reliant on semantic knowledge, but it is benefiting them. So in order to offset some of these declines, they're able to use prior knowledge to help them detect these important changes throughout an activity, to look for guide their attention towards the important parts. But we're kind of stuck with the neuro stuff right now. Uh, why do we see these behavioral differences, but we're not seeing like differences in the univariate brain signal? And why aren't these this memory network that's known to underlie memory in young adults? What's going on with the older adults? So there's a lot of open questions. Everything I've presented so far is correlational too. So we're making the assumption that these knowledge-related benefits that we see at encoding are causing the knowledge-related benefits that we see at retrieval, but we need evidence, some causal evidence of that. And then we're really interested in maybe looking at clusters or individual differences within the older adults. Are some more or less able to activate that relevant knowledge? They may have familiarity. Are they activating it? To what extent are they integrating this novel information with their current schemas? And I'm only using one form of manipulation of knowledge. I've got colleagues, a lot of colleagues in the UK actually that are looking at other measures, not in older adults, but they're looking at how knowledge may influence encoding and retrieval based on biases, prejudices, stereotypes, like political affiliations, et cetera. So there's a lot out there to be explored because this field of what we call event cognition is kind of, and it's like a toddler compared to the old school, the classic memory experiments. So yeah, I just want to say I have a massive team. This was part of the Center for Cognitive and Neurobiological Approaches to Plasticity at K-State. This was the project that I was on, and a whole host of grad students and postdocs and mentors and undergraduates and collaborators at Hoagland and so forth. A lot of people on this. So yeah, I could open it up, go back to other slides. Um,
Excellent. Thank you, Heather. Yeah, let's
yeah.
I've already interrupted you too many times, so I will
Oh,
shut up, but I'll turn it over to the audience, and people can feel free to either unmute, or probably the polite thing to do is just to raise your virtual hand. But if you have trouble identifying your virtual hand, just go ahead and unmute and ask away. So in the absence of other questions, I don't feel rude about asking another one then.
you're fine.
So I'm curious because I know that your work is increasingly focused on Alzheimer's disease
Mm.
as well. And so as I'll ask a naive question as someone who doesn't study Alzheimer's, but I mean, how do you conceptualize some of like what you're finding in older versus younger adults translating to Alzheimer's? Is Alzheimer's just a distinct set of memory related changes that are accelerated in certain individuals?
Mm.
Or is it a unique process that doesn't necessarily overlap with aging per se, but
Yeah, so that's a good big question. But in terms of like what we're studying, the one unique one unique feature of Alzheimer's is that there is some loss of semantic memory as well. So, but not as drastic as what we see in an episodic memory. So that is one angle that we've been trying to leverage though too to see if we could if there's a way to activate relevant knowledge to help people encode and to remember some basic everyday actions. That was like one avenue that we were looking at for behavioral interventions, for instance. But yeah, I know that's not really answering your question, but yeah, no, I see it as a separate. I mean, of course, it's the biggest risk factor for Alzheimer's is age, but that's
mhm,
just a different, uh, I don't know, phenotype, I guess. So that in the brain, like we tend to see more in healthy aging, everything kind of happens anterior to posterior. Like most things that are affected in healthy aging start from the front of the brain and work their way back, whereas Alzheimer's off a different pattern, right? Starting in interrhinal, parahippocampal and moving
mhm, mhm,
in that way. So just like a different, I mean, the hippocampus is hit really hard, obviously, in Alzheimer's and eventually in age. So there are differences that we see there neurophysiologically, but
mhm.
yeah, so I don't treat them as like part of the same spectrum. Yeah, but just, I mean, similar age groups, right? But
Right, right.
yeah, different patterns of behavior. But
Yeah. Yeah. I'm
yeah,
also thinking about just if you have potential to use that eye gaze data to start to, address some of those similar
yeah, that
questions
could
in
be really
clinical
interesting as
population. Yeah.
well. That's a good point. Mhm.
Catherine. Yeah.
Heather, I apologize if you said this already, but so you were saying that semantic knowledge does not seem to decline with age. It's just episodic. Do you
Mhm.
see any sort of protective effects or interactions where people who have really high levels of semantic knowledge seem to, I just don't know if those two
Mm.
systems have any sort of interaction or if they're
Yeah.
completely.
That's a good question. We haven't looked at like everything we've been doing so far has been looking at group level semantic knowledge, right? So it's like people that are familiar or people that are unfamiliar or but we haven't looked at individual differences in that in that knowledge, in those memories. Um, hmm. I mean, that could be really interesting to, but no, my answer is no right now. So far, we have not looked at that, but that'd be almost like looking at an individual differences approach within the age group. Um, on a finer grain level, we do have like familiarity ratings, and you do see some of those relations, like if they report being more familiar with them, or we'll often ask them like, when was the last time you performed an activity like this, or how often do you perform? And that is correlated with memory too. So that may be like a really basic level way of answering that, but I haven't gone any deeper than that though. It's an interesting question. I haven't seen anything within trying to rack my brain really quickly. Hmm. Nothing's coming to mind right now. It's an interesting question though. Yeah.
Um, excuse my voice. So I guess I was kind of thinking along the lines of Catherine as well, and thinking about how can you, and I might have missed this, can you just characterize your sample of older adults? Like how do you characterize them, and what qualifies them as healthy older adults.
Yeah, I definitely did not say that. So thank you for that. We have a database of older adults in the Flint Hills area around Manhattan, and they go through, we do go through some pretty extensive screening processes where we will remove, we have some eligibility requirements. So anything that could potentially affect memory, we exclude based on. So certain medications, history of stroke, history of neurological disorders, some clinical disorders, if they're not on stable medication, like depression or so forth, that can affect memory. Trying to think if I know there's many more. Anesthesia, if they've undergone anesthesia in the past 6 months, just things that may influence memory. But we also go through some basic cognitive screening like the MoCA or so forth. So if they're in the healthy range, then they're included. We have other studies where we are looking at mild cognitive impairment. So we include some of those individuals in those studies, but in the healthy aging that I talked about here. Does that answer the question?
Yeah, I kind of assumed that you were probably screening for a lot of those things, but I kind of was just kind of curious because thinking about what is maybe going on in terms of these kind of individual differences, and if there's maybe something in there you could pinpoint.
With this group, I should have definitely included more of my clinical measures here. So sorry about that.
Okay.
Real quickly, Heather, are there sex differences?
We never see sex differences in the behavioral measures, and I don't believe we had equivalent groups in such a small sample in the fMRI. So the ones that the current fMRI study that we're working with, we are trying to equate based on sex because NIH is really pushing for that. So we may be able to look at that in terms of the neuroimaging data, but we don't actually get any. I had an undergraduate who looked at, because there are some stereotypical activities for men. We used to do like ironing and grocery shopping, and we did try to look at that to see if there was more familiarity within a certain gender. But I don't think we ever found anything reliable based on, one gender being more familiar with balance. If one spouse took care of the finances, one took care of the household duties or something like that. We surprisingly haven't found anything like that, but yeah, unsatisfying, but no, so far.
All right. Well, if there are no other questions, then I want to thank you for really providing us with a lot of rich data and really interesting stuff, Heather. So thank you for taking the time to present, especially being sick and with sick kids in tow, going above and beyond. So we really do appreciate it.
Yeah, of course. It's fun to chat with a new group too. I appreciate your questions. I jotted down a lot of good ideas.
Absolutely. And then real quick, before people do sign off, I will note that there were a few new names and faces that joined. So that's fantastic. It's great to see people here. But I also would say that please feel free to reach out to me, mosconi@ku.edu. If you would like to present, and this can be Dr. Bailey's work is quite advanced in terms of where it is in stage, but we do talks that are of work in early stages, and certainly students are more than welcome. So either feel free to reach out directly or put me in touch with your students if you think that would be appropriate, but we'd welcome all. So with that said, good to see everyone. Hope everybody has a good evening, and we'll see you in a couple of weeks for our next seminar. Thanks again, Heather. Take care.
Yeah.